In this video, I am going to discuss about the applications of MATLAB in control systems, particularly how to define a transfer function in MATLAB. Before we are going to program in the MATLAB, we should know what is transfer function. The transfer function is defined as the Laplace transform of output divided by Laplace transform of input when initial condition is 0. Let the transfer function g of s be given as a ratio of two polynomials in S domain. That is, g of s is equal to n of s divided by d of s, where n of s is the numerator polynomial and d of s is the denominator polynomial. And the coefficients of the Laplace transform variable s in these polynomials are arranged in descending order. There are four methods are available to define the transfer function in MATLAB. Let us see one by one. Method 1. Now we are going to define a transfer function g of s is equal to 5s squared plus 15s plus 10 divided by s power 4 plus 7s cube plus 20s squared plus 24s plus 1 in MATLAB. Okay. In order to clear the command window, I am giving CLC, and clear all command is used to clear the data variables stored earlier in the program. Now I am going to transfer function. For that, we have to use the transfer function command TF in bracket numerator comma denominator. It should be showed in some variable I am considering as sys. Okay. Next, numerator I have to define. How to define a numerator? Here, numerator polynomial is a second order polynomial. It has the coefficients of 5, 15, 5, 15 and 10. So it should be written in row vector. Hence, I am type it as n is equal to 5, 15 and 10. Similarly, for denominator polynomial, d is equal to 1, 7, 20, 24 and 1. So hence I am defining denominator d as a row vector. D is equal to 1, 7, 20, 24 and 1. 24 and 1. Okay. Next, I am running the program. See, I am getting the answer as 5s squared 15s plus 10 and s power 4 plus 7s cube plus 20s squared plus 24s plus 1 as given in the program. Now we are going to discuss about the method 2. In this method, we are going to define the transfer function g of s is equal to 5 into s plus 1 into s plus 2 divided by s squared plus 4s plus 6 into s plus 4 in MATLAB. Okay. In method 1, we have a single polynomial in the numerator as well as denominator. But in case of method 2, we have two polynomials in the numerator as well as denominator. Hence, we have to define separately. For that, I am taking P1. Numerator polynomial has three terms: 5, s plus 1 and s plus 2. Hence, I am going to define 5 as a gain k is equal to 5 Next, P1 is equal to 1 comma 1, P2 is equal to 1 comma 2. So I have to define a numerator. Numerator is equal to k star convolution of P1 comma P2. This command will do the multiplication of two polynomials P1 and P2. Okay. Next, denominator I have to define. So denominators also have a two polynomials. Hence P3 I am defining in P3 is equal to 1 comma 4 comma 6. P4 is equal to 1 comma 4. So denominator is equal to convolution of P3 comma P4. Finally, we have to write transfer function of numerator comma denominator, and it should be stored in the some variable sys. So then I am running the program. See, I am getting the answer as. Let us move on to the method 3. Find the transfer function of the system which has zeros at -1, -2 and poles at -3, -4 and -5. In this method, we are going to use zeros and poles to define the transfer function. So the given problem states that the zeros are at -1 and -2. So I am defining z is equal to -1 comma -2, and poles are at -3, -4 and -5. Hence I am defined P is equal to -3, -4 and -5 as a row vector. Next, I have to define the numerator as polynomial of z and the denominator as polynomial of P. Then I have to define the transfer function as TF in bracket numerator and denominator, and it is stored in the variable sys. Now I am running the program. See, I'll get the answer as s squared plus 3s plus 2 divided by s cube plus 12s squared. In this method, we are going to use the inbuilt function gp2tf in bracket g, p and k. Okay. The problem statement for this function, this method is find the transfer function of the system which has a gain of k. Gain of k is equal to 5, zeros at -1, -2 and poles at -3, -4 and -5. In order to use this inbuilt function, we have to define g, p and k. So first I am defining gain k. K is equal to 5. Next, g is equal to -1 and -2. In this method, we have to define zeros and poles as a column vector. Hence, we are using -1 semicolon -2. Okay. Similarly, for poles also we have defined -3 semicolon -4 and 5. Okay. Next, if you use this inbuilt function, we will get numerator and denominator separately. In order to define as a transfer function, we have to go for another function called as print sys n comma d in S domain. Hence we have to use a single quote yes. Okay, now I'm running the program. I'm getting the answer like this. Thank you.